Hello, students. So, welcome to today's session. Myself, Swayam. I'm pursuing my MBBS at AIIMS Bhubaneswar. So, we'll start with the chapter AIIMS. There are total 25 or 26 questions. We'll go one by one. Okay. So, before attending this session, try to revise all the chemical reactions, physical properties, chemical properties, and the preparatory methods for amines. Okay, go through the NCRT and like was this session. Okay, so let's start. Sorry. So let's start. Which of the following statements about primary amines is false? Sorry, just a minute. Okay, which of the following statements about we have to find the false statement regarding primary amine. Okay, so let's read out the options one by one. Alkyl amines are stronger bases than aryl amines. Okay. So let's suppose it is an example of alkyl amine, CH3 NH. Aryl amine. Aryl amine means benzene. In the on the benzene ring there is a NH2 group. So alkyl amines are stronger bases than aryl amine. Is it true or false? It is true because the basic nature of the amines is due to the lone pair present on the nitrogen atom. So the factors increasing the electron cloud on the nitrogen atom would facilitate to like be it more basic. Okay. So due to the positive inductive effect of CH3, it will increase the electron cloud on NH2. But here on the benzene ring, the electron pair on nitrogen will delocalize and conjugate with the benzene ring double bonds. So the nitrogen atom will decrease. That means the electron cloud on nitrogen atom will decrease. So the basic nature also decreases. Okay. So the alkyl amines will be more basic than aryl amines due to the delocalization of electrons in the aryl amines. Okay. The first option is correct. Alkyl amines react with nitrous acid to produce alcohols. Yes. This alkyl amine will react with nitrous acid to produce alcohol, but this will react with nitrous acid to give this benzene diazonium salt. Okay, RLMs react with nitrous acid to produce phenols. It is false. It will produce benzene diazonium salt. Okay, so the false statement is option C. Let's see the option D also. Alkylamines are stronger bases than ammonia. Yes, am ammonia doesn't have any plus I effect giving groups, but alkyl amines have a plus I effect group that increases the electron cloud on nitrogen. So option D is also correct. Option C is the false statement. Okay, so option C is the answer. Match the following given list, one with their characteristic reactions given in list 2. Select the correct option. Okay. So in column A, the first compound given is a primary amine. So primary amine, what is the characteristic reaction in the amine chapter? Let's find out among these four options. Okay, given in column 2. Just huh. The column 2 come the first reaction is alkaline hydrolysis. No, first uh, like uh, like primary amines doesn't undergo alkaline hydrolysis. Two, with KOH and CSCl3 produces bad smell. Yes, it is the reaction characteristics of the primary amine because the primary amines react with CHCl3 and KOH alcohol will produce isocyanate. Okay, isocyanate that gives bad smell. In it is the test reaction. Okay, it is a test for primary amines. Got it? So one, the characteristic reaction is two. For two, CH3 C triple bond CH. Alkaline hydrolysis. No. Two is gone. Three gives white PPT like precipitate with ammonical AgNO3. Yes, the terminal alkyne will give white precipitate with ammonical AgNO3. So option 2 is related to the option 3. CH3 CH2 COO CH3 gives white like ester gives uh, okay. We have to find out the reaction of ester among the options I like among the reactions I and IV. Okay. So an ester undergoes alkaline hydrolysis. All of you know that to produce an acid and alcohol. So the characteristic reaction will be alkaline hydrolysis for an ester. So option like the compound 3 will correlate with the like the reaction 1. Okay. So the compound 4 that is a secondary alcohol CH3 CHOH CH3. The remaining reaction is Lucas reagent cloudiness appears after 5 minutes. Yes, secondary alcohol will give Lucas reagent cloudiness after 5 minutes. So it is related to reaction 4. So I got two. Let's match the options given below. A. In option A, the 1 IV. No, it is not correct. In option 2, 1, 2, 2, 1. It is also not correct. Option C is also not correct. Option D. Option D is matching with this sequence. Okay. So option D is the correct answer. Okay. Which of the following is more basic than aniline? Okay. It is asking which of the following compounds is more basic than aniline. Okay. So let's draw the structures first. Aniline, then triphenylamine. Triphenylamine means a tertiary amine with three phenyl groups like this. Triphenylamine. All the benzene rings should be at the same size. Okay. But I drew different sizes. Never mind. Then P para nitroaniline. That is on para position of aniline, there will be a nitro group. Benzylamine. Diphenylamine. Okay. So let's find out the basicity order. Okay. So question is asking more basic than aniline. Okay. In this question, first option triphenylamine, the lone pair will delocalize with the three phenyl groups. Okay. So the availability of lone pair will be much less. So it can't be more basic than aniline. Option 2, like paranitroaniline. In paranitroaniline, it is a minus R group. NOT is a minus R group, minus resonance group. So the delocalization of the lone pair will be more than that of aniline. So here also it will be much lesser electron cloud than aniline. Option C, benzyl amine. In this compound, there is no delocalization. It can't delocalize with the CH2. The lone pair in NH2 is not being delocalized. So the lone pair remains constant. Okay. And CH2 is a donating electron donating group. So there is also a plus I effect. So it will be more electron cloud on NH2. Okay. In alanine, and there is delocalization. Here it is there is no delocalization. So benzyl aniline would have more electron cloud on nitrogen than that of aniline. So it will be more basic than aniline. Okay. So option C is the correct answer. Which of the following is most basic in nature? Okay. So we have to find out the basic nature. NH3, CH3, NH2. Okay. CH3 hold 2 NH, C6H5 NH, CH3. Okay. So there is ammonia, there is primary amine, alkyl amine, secondary alkyl amine, and there is a secondary aryl amine. Okay. So basic nature will be among CH3 NH2 and CH3 whole 2 NH, the order will be secondary greater than primary. Okay. Then here the electron lone pair will delocalize with the phenyl ring. So it will be less basic than the alkyl amines. So C6H5 NHCH3. Okay, this will be the order. So which will have the most basic character, that will be the secondary amine, that is CH3 whole to NH, dimethyl amine. Here is written and NH. This is the most basic because two electron releasing groups are present on nitrogen. Also, aromatic amines are less basic than aliphatic amines. So, the basic character of amines will be secondary, primary, then aryl, then NS3. Okay. So, let's move to next question. Question number 5. The compound obtained by heating a mixture of primary amine and chloroform with ethanolic potassium hydroxide. Okay. So, it is asking us to primary amine reacts with CHCl3 with KOH, that is alcoholic. What will be the product? Okay. What will be the product? If we hit them, there will be production of isocyanide. Okay. If it is RaNH2, it will produce isocyanide that has a characteristic foul smell. And the byproduct will be 3KCl, 3H2O. As it is releasing foul smell, it is a characteristic reaction for primary amine, as the secondary and tertiary amines won't produce isocyanide on reaction with CHCl3 and KOH alcoholic. Okay, so secondary and tertiary doesn't give this reaction. So it is a test reaction for primary amines. Got it? So what will be the product? In alkyl cyanide? No. In nitro compound? No. An alkyl isocyanate. Yes, it is correct. The product will be an isocyanate. Let's take an example, that is CH3NH2, CH3Cl, KOH will give CH3NC, plus KCl. So option C will be correct. When aniline reacts with oil of bitter almonds, that is C6H5CHO, benzaldehyde, condensation takes place and benzyl derivative is formed. Okay, this is known as. Look at the reaction. Well, you will find this reaction on like in the chapter aldehyde and ketone chapter, not in amine chapter. Okay, so there is benzaldehyde and aniline reaction. So you might have known that the reactions Gibbs reactions. Okay, there are multiple Gibbs based production. Okay, there is a table in the chapter aldehyde and ketone. Go through that. Okay, you will find the reactions there. So aniline. So there will be production of C6H5CH double bond and C6H5. Okay, and H2. This is benzyl leading aniline. Let's draw the let's write the formula again in the clear page. C6H5CH double bond and C6H5. Okay, this is the product. Okay, it is also called as Gibbs base, not reagent. It is Gibbs base. So when aniline reacts with oil of bitter almonds, you have to remember the what is the name of uh, C6H5CHO. Okay, that is oil of bitter almonds. Condensation takes place and benzyl derived. Benzyl derived, that is this compound is formed. So it is called as Gibbs base. Option C is correct. What is the decreasing order of basicity of primary, secondary, and tertiary ethylamines? Okay, so for ethylamines, there will be two series of basicity. That is on protic solvent and on and in gaseous phase. On protic solvent, there will be a matter of like there will be few considerations like solvation effect. Then there will be hindrance effect. Okay, protonation. Okay, so the sequence is a little altered. Okay, so the sequence is secondary, tertiary, primary, then NSP. We normally think that tertiary would be more basic than secondary, but due to the steric factor, no Lewis acid can react with the sterically hindered nitrogen atom. Okay, so that the tertiary amine will have less basic character than secondary amine. So this is the order for protic solvent, and in gaseous phase, the order will be tertiary, secondary, primary, and the normal because there is no effect of solvation effect or protonation. Okay, in gaseous phase there is normal, and in protic solvent there is a little alteration. So which will be the correct answer? Uh, okay, D. Option D. Look at option D. This will match your our sequence, that is secondary, tertiary, and primary, and NS3. So option D is correct. Mark the correct statement. Methylamine is slightly acidic. Never. Methylamine is basic only. Okay. So it is option A is incorrect. Methylamine is less basic than ammonia. No. Methylamine is more basic than ammonia. We saw the order, and because of the interactive effect of SCH3, there will be more electron density on nitrogen atoms. So methylamine will be more basic than ammonia. Methylamine is a stronger base than ammonia. Yes, it is also correct. Okay, B is also not correct because it is given less basic than ammonia. But C, C is correct because it is given methylamine is a stronger base than ammonia. Let's read the option D also. Methylamine forms salts with alkalis. No, it is also incorrect. So option C is correct here. Methylamine is a stronger base than ammonia due to positive inductive effect. The alkyl groups, which are electron releasing groups, increase the electron density around the nitrogen. Okay, these alkyl groups increase the electron density on the uh, nitrogen atom, so that the lone pair would have more electron cloud. Let's move on to next question. On hydrolysis of a compound, two compounds are obtained. One of which on treatment with sodium nitrate and hydrochloric acid gives a product which doesn't respond to iodoform test. The second one reduces tolerance reagent and failing solution. The compound is okay. The second one will be reducing tolerance reagent and failing solution. So the compound will be HCOH. The second one, formic acid, because formic acid reduces both tolerance reagent and failing solution, and it is a product like uh, product of hydrolysis. So what will be the reactant? Reactant should be, let's go one by one. CH3, CH2, CH2, CO, and CH2. No, there will be different hydrolysis products. It will not produce HCOH. Then CH3, CH2, CH2NC. Yes. Let's take this compound. On hydrolysis, it will break in this manner. It will produce CH3, CH2, CH2, NH2 plus HCOH. The compound A will react with sodium nitrate and hydrochloric acid. It will react with HNO2. That means CH3 and NH2, just CH2, 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 OH. It will produce alcohol. Primary amines react with HNO2 to produce alcohol. And this will not give iodoform. Okay. Iodoform is only shown by the compound of alcohol, that is CH3, COH, C2, that are for showing iodoform reaction. The adjacent to the carbon containing hydroxyl group, there should be an like methyl group. Okay, but in this compound, there is no methyl group adjacent to the carbon containing hydroxyl group. So it won't give iodoform test. So option B will be the correct answer, and A is the primary alcohol, and B will be formic acid. Okay, so and iodoform test will be given by other reaction like other reactant like aldehydes, aldehyde containing CH3, CHO, ketones, ketones having CH3 group adjacent to the carbonyl group. Okay, so let's move on to next question. Acetamide is treated with the following reagents separately. Which one of these would yield methylamine? Okay, let's write the reaction. Acetamide, CH3. Let's go one by one. CH3, CO, NH2. It is acetamide. It will react with NaOH, Br, bromine. So which reaction is it? Hofmann's bromamide degradation reaction. So in this reaction, what happens is the carbonyl group will be released or removed. Okay. And this alkyl group will migrate to the NH2 group. So the product will be CH3 NH2, one carbon one carbon lesser than the reactant. So acetamide will react with NaOH to give methylamine. You have to know the principle of the Hofmann bromamide degradation reaction. Whenever this reagent comes, you have to just remove the carbonyl group and migrate the alkyl group to the NH2 group. Okay, this will be your product. What are the byproducts in this reaction? That is Na2CO3, 2NABr, and 2H2O. This is the byproduct in this whole reaction. Okay, so what is the correct answer here? That is NaOH Br2. Which one of the following on reduction with lithium aluminum hydride yields a secondary amine? Okay, so lithium aluminum hydroxide, it is a strong reducing agent. Just a minute. Oh. Ah, so this is a strong reducing agent. So let's react it with methyl isocyanate, CH3 and C. It will react with LiLH4 to produce CH3 and H. Okay, so it is a secondary amine. So option A is the correct answer because it is producing secondary amine by reaction with LiAlH4. But let's see the other options also. Acetamide, CH3, CEO, NH2. This will, on reaction with LiAlH4, will produce CH3, CH2, NH2. That is a primary amine. Methyl cyanide, CH3, CN. It will react with LiLH4 on reduction. It will produce CH3CH2 NH2. This is also a primary amine. Nitroethane C2H5 NO2. It will also produce a primary amine that is C2H5 NH2. Okay. So all the other options are giving primary amine when whereas the option A that is methyl isocyanate will give a secondary amine. Okay, got it. So let's move to question number 12. The correct order of basic strength of methyl substituted amines in aqueous solution is. Okay. So methyl substituted amines, that is methyl amines, uh, in aqueous solution, that is a aqueous solution, that is a polar, that is polar solution, polar solvent. Okay. In polar solvent, what is the correct order? That is secondary, then primary, then tertiary. This is the order of methylamines basic nature on like in aqueous solution. Okay, but in gaseous state that will be tertiary, secondary, then primary. What are the reasons for this altered sequence or altered nature of the basic character? This is the cumulative effect of inductive effect solvation effect, that is because of the hydrogen bond. Solvation effect comes into the uh, H bonding. Okay. Solvation effect is due to the H bonding. Then steric hindrance also plays a major role in the tertiary amines. Because of the steric hindrance only, we have lesser basic character in the tertiary amine. Okay. So this is the correct order of in protic solvent or polar solvent. It is in gaseous. Let's move on to next question. Before that, let's choose the correct answer. So, secondary, primary, and tertiary. The first option is A. That is the correct answer. Let's move on to question number 13. An isocyanate is prepared by, okay, Friedel-Crafts reaction. No. What is the Friedel-Crafts reaction? There are two parts: Friedel-Crafts acylation, Friedel-Crafts alkylation. On by Friedel-Crafts alkylation, we get the alkyl substituted benzene, and for acyl like Friedel-Crafts acylation, we get COCH3 as a substituent group on benzene ring. So option A is not correct. Perkin reaction is not in your syllabus. Okay, so leave that because it is not given in NCERT. Okay, so carbylamine reaction is giving isocyanate. How? The primary amines. Let's take an example of C2H5NH2 react to its CHCl3, that is chloroform and KOH alcoholic, to give C2H5 and isocyanide. Got it? So primary amines will react with CHCl3 in alcoholic KOH to give this isocyanide structure. So carbylamine reaction is the method of preparation for isocyanide compounds. Option D is given as Wurtz reaction. Wurtz reaction is for alkyl halides. Alkyl halides will produce an alkane by reacting with sodium in dry ether. That let's take an example: CH3X plus CH3X dry ether. It will produce CH3. Yes. Okay. So let's move on to next question. The answer here is option C, that is carbylamine reaction. This is the reaction RNH2 3KOH CHCl3 will produce an isocyanide RNC, and byproducts will be 3KCl and 3. So you have to remember the byproducts also. Sometimes, not frequently, but sometimes it asks about the byproducts also. Okay, so let's move on to next question, question number 14. Which is formed when acetonitrile is hydrolyzed partially with cold concentrated HCl. So let's go through the reaction. Acetonitrile, that is CH3, C triple bond, and acetonitrile will react with concentrated HCl to give. Okay, concentrated HCl, that is hydrolysis will happen, that will produce CH3CO NH2 oxidation. Okay, oxidation and hydrolysis, not hydrolysis much, but oxidation. Okay, CH3CO NH2, that is the acetamide. So what will be the product when acetonitrile reacts with concentrated cold HCl? It will be acetamide, not acetic acid, methyl cyanide, acetic anhydride. The answer will be acetamide. Option B. Acetamide and ethylamine can be distinguished by reacting with. Okay. Acetamide and ethylamine. Acetamide is CH3, CONH2. This is acetamide and ethylamine, C2H5NH2. So a primary amine can be differentiated from primary acetamide, the primary amide compounds by which reaction? Okay, let's go one by one. Aqueous HCl and heat. No, it is not the case. Aqueous NaOH and heat. Aqueous NaOH and heat will produce. In this case, it will produce CH3. As it is a acid, it will react with base to produce CH3CON plus ammonia. So here ammonia gas will be liberated. But here NaOH won't be reacting with C2H5NH2 because both are base. Both are have both are basic in nature. So they won't react and not produce NH2. So so the production of NH2 can be a distinguishable factor to differentiate the acetamide and ethylamine. Okay. So option B is correct answer. Acetamide and ethylamine can be distinguished by heating with NaOH solution because acetamide evolves NH3 but ethylamine doesn't. Acetamide will liberate NH3 that will be seen as bubbling. So CH3CONH2 and plus NaOH, when we heat the reactants, it will produce CH3COONA, that is sodium acetate plus ammonia gas. But ethylamine won't produce that reaction. So question number 16. For carbylamine reaction, we need hot alcoholic QH. And what? Okay. Let's write the carbylamine reaction then. Carbylamine reaction. Carbylamine reaction. Okay. For carbylamine reaction, we need a primary amine plus chloroform plus KOH alcoholic to produce an isocyanide or carbylamine and KCl plus H2. Okay. So it is asking, apart from alcoholic chaos, what will be needed for carbylamine reaction? So for carbylamine reaction, there should be a primary amine along with CHCl3 to produce the isocyanide compound, that is carbylamine. Okay. So any primary amine and chloroform. Option A is the correct answer. Indicate which nitrogen compound amongst the following would undergo Hoffman reaction. Hoffman bromamide reaction to furnish the primary amine. Okay, we need to produce primary amine. Okay, so what will be the reactant? Let's take the first reactant, that is RCO NH3. Here Hoffman bromamide reaction won't proceed. Okay, then on second option, it will also not proceed. The third option, that is RCO NH2. In Hoffman bromamide reaction, what is happening? The amide compounds will release the carbonyl group and the alkyl group attached to the carbonyl group will migrate and attach with NH2. So what will be the product? RNH2. To produce primary amine, we need a primary amide also. So the option C have a primary amide compound, that is RCONH2. So the answer will be option C, that is RCONH2. Okay. So let's move on to next question. RCONH2 in the present case undergo Hofmann bromamide degradation reaction to produce NH2. Okay. Question number 18. Nitration of aniline in strong acidic medium also gives M-nitroaniline because, okay, this is an aniline. Normally, when we like when we give like nitro group, when we add nitro group to NH2 in the basic medium, it will produce NO2 at para and ortho produce like places, because NH2 is a plus R group. Okay, so electron density will be more at ortho and para, so that NO2 group will be attached to ortho and para position. But when we proceed the reaction in an acidic medium, this proton from acidic medium will protonate the amine like aniline group, NH2 group, to produce NH3 plus, and this NH3 plus is no more showing minus like plus R effect, it is showing minus R effect because of the plus charge. It is withdrawing electron. It is drawing electron towards itself, not giving electrons to the ring. So the electron density will be more on the meta group, like meta position. So it is a meta directing group. So the major product will be this Na2 attached to the meta position. So option, let's read out the options. In spite of substituent, nitro group always goes to only M position. No, when we add OH instead of NH2 or NO2, it will go to ortho and para position because it is a positive like plus R group. So it is incorrect. In electrophilic substitution reaction, amino group is meta directive. No, amino group is always para and ortho directive. So it is also incorrect. In acidic medium, aniline is present as anilinium ion. Yes, this will be converted into anilinium ion, and that is a meta directing group or minus R effect showing group. So the substituent will attach on the meta position. So option C is the correct answer. Option D, let's read the option D also. In absence of substituents, nitro group always goes to M position. No, nitro group, look, in absence of substituent, that is a benzene ring, nitro group can go to any position. It is not relative position. So it is not defined as M, like meta position, para position, or ortho position. So we can't tell that it is a meta position or para position. So option D is also incorrect. So option C is the correct answer. In the following reaction, the product A is okay. So here is given and the benzene diazonium salt plus aniline to like in acidic medium to give a yellow dye. What is the chemical formula of yellow dye? So let's draw the structures. N2 plus Cl minus plus aniline. Have you heard of any coupling reaction? Yes. In coupling reaction, two benzene rings will be merged together to produce a diphenyl compound like this. In this reaction, the product will be And the color will be yellow, yellow dye, and it is used as yellow dye. Okay, that is para amino benzene. So let's move on to next question. Options are incorrect here, but the final answer will be this para amino benzene, and the structure will be this. Options given are incorrect. Which of the following will be most stable diazoxide salt? Okay. For the stability of diazoxide salt, we have to stabilize the positively charged N2 plus. And for positively charged N2 plus, either give an a electron donating group or attach it to a resonating structure or conjugating structure. So the options are CH3 and 2 plus X minus. Okay, it is stabilizing to a certain extent, not like a very not in a very good amount. Then option B is giving C6H5 and 2 plus X minus. Yes, it is like it is a strongly stabilizing compound because this positive charge will be resonating with this double bond of phenyl group. Okay, so B is stable. CH3, CH2, N2 plus. It is also alkyl group present, so it is also stabilizing, but not more than this. C6H5, CH2, and it is a benzyl group, and it won't resonate with the N2 plus, or it won't conjugate with the N2 plus group. So it will also be a wrong answer, or it will be also unstable. So the only stable compound here is C. Sorry, C name B. That is C6H5 N2 plus X. Arene diazoxide salts are more stable among the given options because of the dispersal of positive charge on the benzene due to resonance. Okay. In the reaction is not given actually, and we can't form a reaction from here. So let's leave this question. Okay, because it is not clear at all. What is the product obtained in the following reaction? Okay, what will be the product? If nitrobenzene reacts with zinc and NH4Cl, what will it produce? Look, by this reagent, there will be hydroxylamine production. But for this nitrobenzene, which hydroxylamine will be produced? That is C6H5NHOH. That is C6, both amine group and hydroxyl group will be present. So NH and H. Okay, this is a hydroxylamine. Here also the options are not clear. So I'm not choosing an option, correct option, but the correct answer will be this compound. Okay. Aniline insert of the following reaction yielded a colorless product. Why? Okay. Here here also the question is not that like clear because it is given till a series of x. Okay, given till the series of x, but it is asking for y. How can you find out the y if it is not given out? Okay, so we'll find till x. So NH2 react with NaNO2 HCl in 273, 278 Kelvin to produce X. That X will be benzene diazenyl chloride. Okay, just a minute. Okay. Huh. So this is the X. It is asking for Y. I don't know why, but it is given till X. So we'll find X, that is benzene diazenyl chloride. So question number 24. Nitrobenzene can be prepared from benzene by using a mixture of concentrated HNO3 and concentrated H2SO4. We saw this reaction, electrophilic substitution reaction, on the previous chapter, that is hydrocarbon. Okay. So for that reaction, a nitrating mixture, that is concentrated HNO3 and concentrated H2SO4 were taken, were being taken. Okay. So in that nitrating mixture, that is HNO3 concentrated and H2SO4 concentrated, which will act as base and which will act as acid. Let's see the reaction only. By reacting with each other, it will produce NO2 plus H2O and HSO4 minus. So H2SO4 will donate one proton to produce HSO4 minus. So H2SO4 is a acid. HNO3 will like donate OH minus to produce NO2 plus. So it will be a, it is acting as a base. So HNO3 will act as base. I'm writing here HNO3 in nitrating mixture. HNO3 will react with base and H2SO4 will react with acid. It will release OH minus, it will release H plus in nitrating mixture. The correct statement regarding the basicity of aryl amines. Okay, let's read the options. We have to find out the correct statement regarding aryl amines, basicity of aryl amines. Aryl amines are generally less basic than alkyl amines because the nitrogen. Okay, up to this it is correct. Aryl amines are less basic than alkyl amines. Next is given the reason for that, because the nitrogen lone pair electrons are delocalized by interaction with aromatic ring pi electron system. Yes, because of the delocalization of the lone pair of nitrogen with the benzene ring, the electron cloud on the nitrogen atom will be very much less. So the basic character is decreased by that factor only. Okay. So option A is the correct answer. But let's read out the other options also. Aryl elements are generally more basic than alkyl elements. It is false in the first line only. Aryl elements are generally more basic than alkyl elements. It is also not correct. Aryl elements are generally more basic than alkyl elements because the nitrogen atom in Aryl elements is sp hybridized. It is also not correct because it is given Aryl elements are more basic than alkyl elements. It is also not correct. Then let's move on to next question. Okay, what is the reason for aryl elements are generally less basic than alkyl elements due to the following factors? Due to resonance, obviously I told that, and the other factor is lower stability of anilinium ion. Okay, after reacting with an acid, anilium ion will be formed, and anilium ion is unstable. So it is not feasible to form anilium ion by reacting with acid compounds. So it will have a less basic character. Method by which aniline cannot be, okay. It is the last question of our today's session. Let's see the question. Method by which aniline cannot be prepared. Okay, which method can produce aniline? Option A is giving hydrolysis of phenyl isocyanate acidic solution. Okay, phenyl isocyanide. Okay, it won't. Just a minute. Yes. Uh, okay. Hydrolysis of phenyl isocyanate with acidic solution. It can be produced. The reaction will be, it is the isocyanate, benzene isocyanate react with H2O in H plus. Hydrolysis by acidic medium. It will hydrolyze in this manner to produce NH2 here. So aniline can be produced by hydrolysis. Degradation of benzamide with bromine in alkali solution. Let's see. Benzamide, CONH2. It will react with bromine in alkaline solution, that is NaOH. It is Hofmann's bromamide degradation reaction. So this group will migrate to NH2. So it will also produce an aniline. So reaction B also produce aniline. Reduction of nitrobenzene with H2 palladium. Nitrobenzene. Let's draw a nitrobenzene. It is nitrobenzene. It reacts with hydrogen and palladium to give, okay, hydrogen and palladium will reduce NO2 to NH2. Okay, so option C or reaction C is also producing aniline. So the only option left is D, and it will be the incorrect option. We know, but let's read the option. Potassium salt of phthalimide treated with chlorobenzene followed by hydrolysis with aqueous NaOH solution. Okay, for phthalimide substitution reaction, we need, like, the reaction undergo nucleophilic substitution reaction in the last step, but the aryl compounds or chlorobenzene can't undergo the like the nucleophilic substitution reaction because the like the halogen groups create a partial double bond with the benzene ring by resonating structures. So the double bond is very much difficult to break through the substitution reaction. So it will not undergo substitution, nucleophilic substitution reaction. So the last reaction won't be possible to produce aniline. So the last reaction is not correct according to the preparation of aniline. Okay. So this was the last question of our session today. Okay. I hope you all understood all the questions like correctly. Okay. Please go through your notes and NCERT because it is a very large chapter. You have to remember uh, various taste reactions, specifically tolerance reagent, Pelling reaction, etc. Okay. So thank you.